everyone, this is Ms. Cave with our study guide for Unit 5. So we are going to be going over the questions from the study guide. So I apologize that the video I had made earlier did not go through, so I am making a new video. So I hope that you've tuned in to watch. Let's go ahead and get started. So the first question that we went over in class, but I'm going to talk to you about again, is about Richard. On Monday, Richard worked for 4 hours and earned $36. On Tuesday, he worked for 6 hours and earned $54. On Wednesday, 5 and 45. So today in class, we discussed this, and we found that his earnings, yes, were proportional. And the reason we know is because we're multiplying. Because the relationship between, so if we take 36 and divide it by 4, we get 9. If we take 45 and divide it by 5, we get 9. So each time the relationship between hours and money is a times 9 relationship. So the rate of change then, we just calculated by talking about the proportionality. Our rate of change is by taking our y value, which in this case is the money earned, dividing it by the x value. We call that m for proportional rate of change. So we're going to take any of these numbers. We can even take the last one. We could take, or the second one, we could take 54 and divide it by 6, and we get 9. So the rate of change is actually $9 per hour. All right. So taking that, we can now write an equation. We calculated m as our rate of change. We just plug that into our equation. So y equals 9x. If he works 7 hours on Thursday, we just plug in. Remember, hours are represented by x. So we're going to plug in that to the x. So y equals 9 times 7. So y would be equal to $63. And then for the second one, how many hours did Richard work on Friday? We use the same equation, y equals 9x. But this time, our 81 is our y value. So it's 81, his earnings are equal to 9 times the number of hours he works. So to figure this out, we have a multiplication equation. We're going to divide both sides by 9, and x is going to be equal to 9 hours. Okay, so that was number 1, and that's what we went over in class. So let's keep going. Number 2, we have a table of values, and we're calculating the rate of change. Rate of change in a proportional relationship is found by taking your y value and dividing by your x value, because you're basically looking at what we multiply x by to get y. So we could take any of these values. We could take the last one because we know it's proportional, doesn't matter. I'm going to take 6.6 and divide it by 6, and m is equal to 1.1. So our rate of change, which is also known as our slope, is 1.1. And again, this is for proportional relationships. Next problem, number 3. We're looking for the equation that would represent this proportional relationship. So we're going to do the same thing, but you notice that now we have equations, and our equation for a proportional relationship is y equals mx. So to figure out the m, remember to find m for a proportional relationship, we're going to divide y by x. So I can pick any of the values from the table. So I could take the 6.3, divide it by 3, and m is going to be equal to 2.1. I then plug m into the equation, y equals 2.1x. So my answer is C. So whenever it's proportional, to figure out the number that you're multiplying, you're just going to take this number and divide it by that number. to get your slope or your rate of change. Next problem. Now we're looking for which table represents a proportional relationship. Proportional, meaning we're multiplying. And we could also be dividing because we could be multiplying by a fraction. So multiplying or dividing is proportional. So in other words, if I'm multiplying by 3 times 3, that's the same thing. If I'm dividing by 3, that's the same thing as multiplying by 1/3. Okay, so dividing by 3 is the same thing as multiplying by 1/3. All right, so if we look at the tables, we can just use our calculators. We can divide y by x, so 5 divided by 1 is 5. 6 divided by 2 is 3. Okay, so you can see that this is not proportional because if it was, it would be the same number. For the table down here, if you look at the relationship another way, 1 times 1 is 1, but 2 times 1 is not 5, 3 times 1 is not 9, so that one is not proportional. Let's look at C for this equation. For this, it's a little harder to see, so I'd probably take my calculator, divide 3 by 2, and I'd get 1.5, right? I'm just dividing y by x. And then 5 divided by 4 is 0.8. So the slope for that would be 0.8 if it was indeed proportional. So they're not the same. It has to be constant. So we look over here. If I divide y by x, it's 3/2, which is 1.5. 6 by 4 in a calculator, 1.5. And again, I'm dividing. 9 by 6, 1.5. So this one is proportional. Even though the numbers, you're actually multiplying by a decimal, you can have a decimal or a fraction for slope, as we've looked at in class. Our next problem, we are going to calculate or plot 3 points on a line that passes through this and has a slope of this. So our 5, 3 here, that's our x and our y values, okay? We know that it passes through that, so we can go ahead and plot a point at 5, 3. What we also know is that the slope is 3 over 5. So slope is 3 over 5, our rise is 3, and our run is 5. So I'm going to go up 3, and over 5. 1, 2, 3, 4, 5. Plot a point. I'm going to go up 3 again. I'm going to go over 5. So it's our staircase, remember, your rise, that's my rise over run. Rise over run. You're going to go up or down first. And then we're going to take this and put a line through it. And that's our line with 3 points on it for slope. The next one, we're not given the graph, but we're given the function of the graph, the equation of the graph. And what we know is y is equal to 1/2 x. So for this, all you're going to do is plug in these values. So let me show you. So if y is equal to 1/2 x, y being our second value, I'm going to plug in 0 from here, equals to 1/2, oh sorry, that's y, they're just both 0. And then our x value here, times 0, and we'll see if it works. 0 equals 1/2 times 0 is 0. So this would be on that line, okay? Let's try these two numbers. Y, 2, equals 1/2, x here is 1. So 1/2 times 1 is 1/2. Doesn't work. So this one is not the function, points on the function. 3, 6, y being 6, equals 1/2 of 3. Okay, if I find half of 3, that's 1.5. 1.5 is not equal to 6. I'm going to cross that out. It brings us to our next problem, 4 and 2. So y is 2 and x is 4. So let's see if 2 is half of 4. 2 is equal to half of 4 is 2. So this one would work. This next one, 10 and 5, same thing. Y, 5 is 5 equal to half of 10, and 5 is equal to 5, right? Half of 10 is 5. So this one is correct. And then the last one, 4 and 8, y, 8 equals 1/2 times x. 1/2 of 4 is 2. 2 is not equal to 8, so this one is not going to work. So again, when you don't have the graph in front of you, you can simply go back and plug in the values and see if they're equivalent, just like when we checked our equations. Okay, number 3. So now we're looking for a proportional relationship, so we know it's proportional, and we want to match our graph to our equation. So remember that the number that comes before the x, that's our rate of change, it's also our slope. Slope is equal to rise over run. So you can see the slope in each of these. For A, it's 4/3. For B, it's 3/4. For C, it's 3. And for D, it's 4. So we're going to figure out what the slope is of this line and then compare it to the equations. So I'm going to take any point. Let's get to take this one in the center at the origin. And then I'm going to look for another point that lines up in the very center. So I'm going to take these 2 points, and then I'm going to calculate my rise over run. So I went up 3, that's my rise, and I went over 4, that's my run. And slope is equal to rise over run. So we're going to pick the equation that has m equals 3/4. So A is 4/3, it's been switched. B has a slope of 3/4. C has a slope of 3, and D has a slope of 4. And that's how you do it. So when you have a graph, you're going to find the slope and figure out which one has the same m value. Number 4, same thing, but this time we have different graphs to choose from. We're given this equation, so that means the m value is 2/3. That's our slope. That's our rise over run. So we're going to calculate the slope for each of these lines. So if I start here and I go here, I'm going to go up 2/1. So the slope for that would be 2/1, which would be m equals 2. Okay, that's not that. So that one doesn't work. For B, we're going to go up 3, go over 1, 3/1. So our slope is equal to 3. And that's not what we're being asked to find. C, take this point again, maybe this point here. I'm going up 3, going over 2. Okay, maybe that one's it. But remember, our rise is 3. Our run is 2. So it's rise over run. So it's 2/3. This is 3/2. So not that. We can see this last one. Take this point and this point. I go up 2. I go over 3. So my m is rise over run. So it's 2/3, which is the same. That's what we're looking for in that equation. So the answer is D. So just be really careful not to switch your rise with your run when you're identifying equations. Oops, I think there's a number 5 down here. Is there? No? That's it. Okay. 710C. Now we're looking at the equation y equals x plus b. So we're not looking at proportional relationships anymore. We're looking at additive relationships. And we're writing an equation for that. It says Maria has 3 ceramic cats and she wants to buy some more. So we're going to write an equation for that. So she's starting with, her starting point is 3. So before she even has any days going by when she gets new cats, she has 3 cats. So our equation is going to be y equals x plus 3. So no matter what happens to x, we're always going to add 3 to it because she started with 3 cats. Number 2, we have a table of values, and we're looking for the relationship. It tells us the relationship between x and y. And maybe we don't know if it's additive or proportional, so we can check it out by dividing y by x, right? If I divide -6 by -2, I get 3. If I divide -5 by -1, I get 5. So right there I can see that it's not going to be a proportional relationship. So now let's look and see what's happening between x and y. So what we can do is then subtract. So I can take -6 minus -2. I can use my calculator. And then that's plus a positive, so it's -4. And I can try the same thing with -5 minus -1. And if I do that on my calculator, -5 minus -1, I can see that I'm going down by 4. So that's the relationship. The relationship from x to y is going to be -4. So that is that additive relationship, that number that we're adding to x to get y, is called the y-intercept. So our y-intercept for this table is 0, -4. So if we were graphing it, we would have a point on 0, -4. And again, if it's proportional, you're looking for the number that you're multiplying, and if it's additive, you're looking at the number that you're adding. And if it's subtracting, you're just adding a negative. Number 3, the table here shows the relationship between x and y. Again, I can see because it's not 0, 0 that it's additive. And I'm looking for a verbal description to a practical problem. So our starting point is 6. So a verbal description might be Miss Cave has $6 saved. Okay, because that's our starting point. And earns $1 per week. It's just a scenario that would work. Now you might not see where I got the 1. Because I know it's additive, it's going to be x plus b, right? And I know I'm adding 6, y equals x plus 6. Now I can check to make sure that it's 1x by finding the difference in y. 18 minus 10 is 8. And the difference in x, 12 minus 4 is 8. So that's our rise over run again. So our change in y would be 8. Our change in x would be 8. So our slope is 1. So that's why it's just 1. And that's how I got my 1 per week. So the y-intercept here, just like we talked about, is going to be 6, the number that we're adding. And the equation, I already wrote it over here, but I'll write it again. Y equals x plus 6. Okay. Let's look at number 4. Now we're looking at a relationship between Kai's age and Lou's age. Okay, so I'm going from 1 to 8. Is it a times 8? It could be, except that I'm also going from 4 to 11. That's not a times 8. 10 to 17, not times 8. So if it's not proportional, it's going to be additive. So what am I adding? I'm adding 7. So you can see that Kai's age is 7 years older than Lou's age. So whatever Lou is, we could say that's x and this is y. We add 7 to Lou's age to get Kai's age. So Kai's age is going to be equal to Lou's age plus 7. So this is our equation. And you could see how somebody might get this here, right? Because if they just did the first 2 coordinates given, 1 and 8, they might think it's a times 8, but you got to check the whole table. Number 5, now we're looking for the relationship between x and y again. I know we're in the additive section, but it could be proportional, so we always want to test for that by dividing y by x, y by x, y by x to see if it's proportional. We can see here that it's not. So now we can subtract y minus x. So 4 minus 5 is -1. Okay. 1 minus 2 is -1. -4 minus -3 You guessed it, -1. So our y-intercept is -1. So the way that we represent this for an additive relationship is y equals x plus b. So this would be y equals x plus -1 or y equals x minus 1. Same thing. So our correct answer is C. All right. Now we're graphing lines using y-intercept. So we were graphing before with slope, and now we still are going to use slope because it's going to have a slope of 1, right? Because our formula is y equals x plus b. But this time, we're going to start with our y-intercept. We can't start with 0, 0. So y is going to be equal to x minus 4, because I know that it has a y-intercept of -4. So y-intercept means 0, -4. That means I'm going to have a point 0, -4. And look, I've got the other point, 3, -1. So once I figure out those 2 points, I can form a line. So I'm going to plot them on my graph, 3 on my x, -1 on my y, 0 on my x, -4 on my y, and then I'm going to make a line. Okay? So again, when you're given y-intercept, you know that the coordinate is going to be 0, -4, that -4 being our y value, the place where the line hits the y, and then our second coordinate is 3, 1. Just be careful that you're doing x, y. Don't confuse it with slope with rise over run. When you have a coordinate, you are going to find the x value first and then the y value. Okay, we have graphing line. This time we're not given the y-intercept, but we need to find it. Our y-intercept, if you look, it's the number that's being added or added to x. So it's -3. So our y-intercept, we're going to plot our point at 0, -3. And again, if it helps, you could highlight where your y-intercept should be. So our y-intercept is going to be here at -3. And then now how are we going to get more points? I don't have another point. Well, I know the equation of the line is y equals x minus 3. My slope here, there's no number there, so it means it's 1. So if there's no number, it's 1 over 1. So my rise is 1, and my run is 1. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. Sorry, my stylus isn't the best on this tablet. So then you're going to make your line. I'm going to try to make a better one this time. Right here. Make it go through those points. There we go. So now we've graphed a line. Y-intercept 0, 3. Oops. Our y-intercept was 0, -3. And then we used the slope, the value in front of x, 1, to get the rest of the points. Okay. Now we have a graph and we're trying to match it with the equation. So let me show you an easy way to do this. Okay. Proportional, not proportional first. I know if it's proportional, you should be writing these notes. I know if it's proportional, it's going to pass through 0, 0. Okay. Does this graph pass through 0, 0? No, it doesn't. It would have to pass right here and it doesn't. So it's not proportional. So if you look at your equations, the ones that have multiplication, only multiplication, we're going to cross those out because it can't be proportional because it doesn't go through the origin. So now we're going to look at the other two. We're going to look here at our y-intercept, the place where the graph crosses the y-axis. And that location is going to be 0, 6. Now, is this a +6 or a -6? It's a +6. So our equation is going to be y equals x plus 6 because it's a +6 for the y-intercept. Okay, now we're on to 710E, the last page. We have a couple of word problems. Stephen went to play video games in Games Galore Arcade. Games Galore charges $150 for each game played. We're going to represent that relationship with y and the number of games played using a table, graph, and an equation. For this, we're going to focus on whether it's proportional or additive, and we're going to explain. We don't really have room to create all those things. So I'm going to make a table, though, to help me make sense of this. X being the number of games, Y being the cost. So if he plays one game, it tells us it's $150 per game. So if it's one game, it's $150. Okay. If it's two games, what are we going to do? Well, we're going to multiply by $150. So 2 games would be $3. 3 games, we're going to multiply by $150 again. So 3 games are going to be $450. So what are we doing here? We're multiplying. So what type of relationship do we have? We're multiplying, so it's going to be proportional. And if we graphed this, we would see that it went through the origin. All right, let's take a look at Sam's situation. Sam went to play video games in the arcade, different arcade. They charged $10 just to get in and $1 per game played. Okay, so let's go ahead and just graph it, or excuse me, make a table. So before he plays any games, how much does he have to pay? That's right, $10. It tells us right here, $10 just to get in. And then it's $1 per game. So if he plays one game, it's going to cost him $11. If he plays two games, it's going to cost him $12. So you can see it's going up by 1 each time, and that's going to end up being our slope. But if you look at the relationship between x and y, it's not a multiplication relationship, it's additive. So this is an additive relationship, and if you look at what's happening, we're actually adding 10, right? You got that 10 starting point. So y equals x plus 10. 0 plus 10 is 10, 1 plus 10 is 11, 2 plus 10 is 12. All right, number 3. Now we're matching a graph to a table of ordered pairs. So for this one, let's see if I can make this a little smaller so we can see the whole thing. Okay, there we go. So for this problem, we're going to match, pull it down just a little bit, the number. There we go. The graph represents which ordered pairs. So you basically for this, just go through your tables and look at your points. Like I'm going to start with an easy one, 4, 2. 4, 2, table A. Does it go through the line? No, it doesn't, so I'm going to cross that one out. For B, I'm going to do an easy point, 4, 0. 4 on the X, 0 on the Y, goes right there. Does it go through the line? It doesn't, so we're going to cross that one out. Okay, C, 0, negative 2. I'm going to go with that one because that's our y-intercept. 0, negative 2. Is it on the line? It's not. So it's got to be D, but let's go ahead and prove it with, let's see, 1, 3. 1 on the X, 3 on the Y. There it is. Let's go ahead with 3, 5. 3 on the X, negative 2, 0, and negative 4, negative 2. You can see that every single point that's in that table is on the line. So the correct answer is D. Okay. Which graph goes with these ordered pairs? Kind of the same thing. So I'm going to be looking for these points on the graph. So negative 2, negative 2. Let's see if it's here. Nope. So it's not A. Negative 2 on B. Okay, it's here. But we got to have at least all of the points. So let's try. We did that one. Let's do 1, 1. 1, 1's there. 2, 2. 2, 2's there. And negative 1 is there. So the answer is going to be graph B. But you should have checked some of the other ones, like 1, 1. It's not there, so it's not going to work. 1, 1 over here, it's not going to work. So with tables and graphs, probably the easiest way to figure out which one works is just by plotting the points into the graphs and seeing if they're there. Okay, so now we're looking for a graph that represents the same relationship as y is 4 more than x. So let's think about that verbally. Y, when we're translating equations, y is equals 4 more than x. So it's going to be x plus 4, more than being addition. So again, the easiest way, this is an additive relationship, so we can eliminate A because we're not multiplying. Let's see. We can eliminate B, it's not proportional. And so now we're down to C or D. So the y-intercept for this is going to be 0, 4. The number that you're adding is the y-intercept. So if you look here, that line crosses the y at 4. So our answer is going to be C. And just for fun, let's look at D and think about what this relationship would be. Okay, the y-intercept is negative 4, so this would be y equals x, not plus 4, but minus 4. So this one's incorrect. So the correct answer is C. All right, that's it for our study guide. I hope that you will look it over, maybe try some more problems like these on IXL, and make sure you finish up your IXL before class tomorrow. I hope you have a wonderful evening, and I'll see you tomorrow.